This is Euclid Book 5, proposition number 14, and this one is a lot easier than the last one. It says if a first magnitude, of course this is a magnitude right here, which is A, okay, has to the second the same ratio as the third has to the fourth, which this line here is 3 inches long, this line here is 2 inches long, this line here is 1.5, and this line here is 1. So they are definitely in the same ratio. Okay. And the first magnitude is greater than the third. Well, obviously this line here is longer than this line right here. Then the second is also greater than the fourth. Well, the second is going to be greater than the fourth. Okay. This is greater than this, and this is also going to be greater than this. How do we prove that? Well, since A is greater than C and B is another magnitude, therefore A has to be a greater ratio than C has to be. Okay? So, A is to be greater than C is to be. And this is Euclid Book 5, proposition number 8. But A is to B as C is to D, therefore C has to D a greater ratio than C has to B. Okay? The ratio of C to D is greater than the ratio of C to B. I know that doesn't look like it that way, but in truth it exactly is. I checked it out myself, and this reasoning goes by Euclid Book 5, proposition number 13, which we just covered in the last lesson. But that to which the same has a greater ratio is less, therefore D is less than B. Okay? D is less than B, so that B is greater than D. B is greater than D. Okay? And this is by Euclid Book 5, proposition number 10. If you need to look that up, you can. Go right ahead. Alrighty. And of course we can go on with this. We can say if we can prove that A equals C, then B equals D, and if A is less than C, then B is less than D. We can prove that if we wanted to. If you want to go ahead and do that, go right ahead. I think you're going to get the basic idea here. I will tell you more in a future video. Stay tuned.